All right, we already passed 4 minutes. Let's get started. Good morning, good evening, everyone. Let's continue with the yesterday session. Before that, I can quickly recap what all we discussed in our yesterday session. We started with the introduction about myself and the course curriculum, course content, course duration, course timing, and the course fees, and what is the registration process. That's basic things what you wanted to know about this particular course, and then started with some of the topics on the RAC part. Like we started with the differentiation between the standalone versus RAC, why RAC, and what are the advantages of RAC, and what are the installation process comparison with the RAC and the standalone. And we talked about the different types of databases and the different CID files, control redo and data files in case of RAC, in case of standalone, and which all files are saved, which all files are not saved. And also we see in couple of demo on the lab exercise, how we can validate the files and the databases, how the RAC database looks like, how the standalone database look like. So that's basic things what all we discussed. Right. So in this today's session, let's talk about RAC architecture and networking, and followed by some of the clusterware startup sequences and why clusterware, what is ASM, what is database, and type of databases. So let's continue with our yesterday session, right? Right. So whoever new, I can quickly run through in next 5 minutes about my course and the course curriculum. Right. So if you are missed out my yesterday session or new for this session here, these are the demo sessions today and tomorrow. Sorry, yesterday and today was the two demo sessions. We conducted yesterday one session, and today is a continuation of that second session. So some of the facts we talked about in our yesterday's class. One important thing is about the course curriculum. So just quickly have a look on that course curriculum. We'll start from the before the course curriculum. Let's quickly talk about the course timing and the course duration. We already talked about that yesterday, but still I wanted to highlight one more time today. So today and tomorrow, yesterday and today, Saturday, Sunday, are the two demonstrations. So what we are attending, this is 2nd April, is the second demonstration. And this is a weekend batch, remember this. So many people still, I got a lot of pings. Can we have a weekdays batch and weekday classes? Again, there is no weekday classes for this RAC course. It's only weekend classes, Saturday and Sunday. So 8 hours in one weekend, 4 hours on Saturday and 4 hours on Sunday, 4 hours on both the weekends, Saturday and Sunday, 4 hours Saturday, 4 hours Sunday. And this course is of 8 weekends. So remember, this is only on Saturday, Sunday, 8 AM IST to 12 PM IST, 4 hours on Saturday and 4 hours on Sunday. That will be in Eastern time. It will be 10:30 PM EST to 2:30 AM EST. And it's of 6 weekends. And actual course is starting on 8th April 2023, next coming Saturday. Right. So these two are the weekend what we're conducting a demo. First and second, first Saturday and second Saturday are the demo sessions, and followed by 8th and 9th are the one which we're going to start the actual course. So followed 8th weekend, 15th, 22nd, 29th, 6th weekend, and a 13th weekend. So these are the 6 weekends we're going to complete this course. Right. The course fees is 15 K INR, Indian rupees. So that will be 185 US dollar. And these are like Zoom session, live online classes, which is of 19C version and will be conducted on the Linux platform. And again, these are the email address on WhatsApp number +919880616848. You can feel free to ping me on my WhatsApp number for more details or more things you want to know about this course. And if you want to drop an email, you can drop me on this email ID, mallikarjun.ramadurga@gmail.com. Right. So, and if you want to look for the course curriculum, so you can look for this link here, already opened in the browser here. So this is my course curriculum, already explained in details in yesterday's session. So just go through that. So we'll start with the cluster-aware understanding, cluster-aware architecture, cluster-aware networking, and start with the Linux or installation Linux understanding and networking and the shared disk and different types of networking, SCAN, VIPs, public IPs, virtual IPs, and followed by installation of my cluster, ASM, RAC, and RAC databases, and followed by understanding of ASM architecture and ASM administration, and my clusterware administration, SRCTL versus CRSCTL, and restarting your cluster, restarting your database, restarting your instances, and restarting your server or node itself, and your routing disk, OLR, OCR, SCAN, VIP, public IP, cluster resource, and database resource, and your RAC database administration, your CID file, your SP file, password file, control file, read log files, arcalog files, system, sysocs, undo, user, and any custom data files or the table space, and followed by your backups and recovery database, your RAC database backups and recovery, how we're going to perform the RAC database and restores and recoveries and cloning and the database refreshes, and the different types of listeners, scan listener, and your local listener, your um, database listener, ASM listener, net listener, so many listeners we're going to talk about, and your multi-tenant architecture, CDBs and PDB administration and understanding concepts, all those things here. And your ACFS, RAC one node, different types of database, RAC one node database, RAC database, standalone database, restart database, and the patching, GI patching, Oracle home patching, data patching, OPatch versus OPatch auto, and your database upgradation, various methods of your database upgradation, right? Node addition, node removal, you're converting RAC, non-RAC database to RAC database, right? Followed by your resume and cover letter preparations, and mock interviews and sample entry questions and answers, right? So this is in brief about the course curriculum. And having said that, if there's any particular extra topics or anything you want to discuss, so those all will be discussed as part of extra classes. It may be your wallet, or it may be your OEM, or it may be your licensing, or any topics, any extra topic other than this whatever mentioned here will be taken as the extra classes and will be discussed after end of the course. Right, so that is about the course curriculum. And if you can go to my blog and click here for more information, so that's going to take you for the upcoming batch schedule. So in this upcoming batch schedule here, whatever the course, database course and the RAC course. So right now I'm conducting, these are the two courses, database and RAC. Database is starting on 13th April. This RAC is started yesterday. You can go ahead and then click on this link here and you can register for the course. And then once you register, I can connect with you one-to-one, and then I can further continue with your payment process and other details. Right. You can directly go to these links, or you can ping me on my WhatsApp. Anything works for me. Right. And again, we talked about that prerequisite yesterday. Again, one more time, the prerequisites is you should have a prior database knowledge, at least basic understanding your database, how the database works, and what are the database files, and what is your SP file, P file, and some of the basic knowledge you should be aware of that. Otherwise, your RAC, you will not be able to get it. You will not be able to understand. And your laptop should have minimum 16 GB RAM and 100 GB hard disk. It may be HDD or SSD. So this is your other prerequisites. In order to do a practice, or in order to do set up a lab on your laptop or desktop, you should have minimum of 16 GB RAM and 100 GB hard disk. Otherwise, you will not be able to set up. You will just be able to watch or participate in the course, but you will not be able to do a hands-on. Right. So that's about the prerequisites, DBA knowledge, and your database, your laptop requirement. Right. So with that, let's get started. If no questions, again, as I said in this today's session also, you are all allowed to unmute yourself, and you can ask any questions or queries or any concerns you have it, or you can use this chat window here and you can post any questions or queries. I can, happy to take that. I'm happy to answer that. I got one questions here. My laptop is of 8 GB. I have extended to 16 GB and SSD. I have extended to 1 TB. So yeah, it is compatible. So if you have 16 GB RAM and 100 GB hard disk, you can pretty much practice that works. Right, let's get started now. What we're going to talk about today, continuation. So we'll talk about this RAC architecture and the RAC networking. Right, so before that, any questions on the course curriculum part? So whatever I talked about, this course curriculum or the course content or the course timing. So remember, 1st April and 2nd April, yesterday and today, Saturday and Sunday, this is second class. That's a demo classes. So 2 hours, yesterday we conducted demo classes. Again, today also we're going to conduct these 2 hour demo classes. So we're all attended with this particular Zoom link. And again, RAC course curriculum already discussed. And so actual course is starting on 8th April. That's coming Saturday. So again, many people will get confused. The demo sessions are only 2 hours. Yesterday and today, it's a 2 hours each demo sessions. But actual course is starting on 8th April, Saturday, and it is of 4 hours on Saturday and 4 hours on Sunday. So it will be 4-hour classes on 1 week, one weekend. The Saturday 4 hours and Sunday 4 hours. That will be 8 AM IST to 12 PM IST, 8 to 12, 4 hours. And that will be 10:30 PM EST to 2:30 AM EST. So that's in Eastern time. Right. So again, already posted here course curriculum link in the chat. I can post you one more time. You can go through that.
And Malik, 4 hours is continuous or else?
Yeah, there will be break in between. So we'll conduct 2 hours and then we'll take 10-15 minute break and then we'll again rejoin.
Yeah, sure.
All right. Right. So if no further questions, let's get started with the new topic. That's a RAC architecture, networking, and the RAC architecture part. So again, there's one more question here, 8 GB RAM and 500 GB SSD. 8 GB RAM will not work because we need a minimum of 16 GB so that you can work without any issue. Right, so let's take my notepad here. Okay, so let's talk about the RAC architecture and the RAC networking. So my job is to build 2 node RAC. This is my node 1 and node 2. Let's say I can say this is my node 1. Many people will tell in case of they're working on RAC, they will say node 1, node 2, RAC, server 1, server 2, host 1, host 2. These are all your Linux server. There's nothing special about that. Node 1 or node 2 means your Linux server 1, Linux server 2, where you have your plus ASM 1 is running here. And you have your plus ASM 2 is running here. Right, so that's correct. We talked about that yesterday. And if I can quickly show you on that. So I have this node 1. I'll put it over here. I have this node 1 and then I have this node 2. I'm just comparing my real setup here. I have this node 1, node 2, host 1, host 2, or server 1, server 2. I have plus ASM 1 is running here and I have plus ASM 2 is running here. Right, so if I can, we talked about yesterday. So we are going to install grid software on both the servers. This is my grid software. We're going to download it and we're going to install it on both the server. This is my grid software. If I go inside and do ls, right, this is my grid software. We're going to download it from Oracle eDelivery and then we're going to install it. And we already talked that we're going to use a tool called grid setup.sh. Using this grid setup.sh, we're going to install the grid software or the ASM software or the Clusterware software. Right, so once you install your ASM, on top of that, you're going to create your database instance, DevDB1, DevDB2, two database instances. If you see here, ps-f grep smon, you have your ASM instance 2 and you have DevDB instance 2. And if I can go to node 1, ps-ef grep asm1. I have my ASM instance 1 and DB instance 1. These are the two database instances. And we talked about that these database instances are residing under shared storage, whatever the shared storage between this node 1 and node 2. So let's put some shared storage here. And I can say this is of 100 GB each. These are the disks, 100 GB and again 100 GB. I'm giving a rough example here. So let's say with the help of this disk. So these disks are basically, I'm gonna connect on both the servers so that whatever data is written on this disk is accessible from both the servers. So I am gonna create my database here on this shared disk here, DevDB. This is your actual database, and this database is accessed by both the instances. Right. So what I'm talking about, let's go to our yesterday's demonstration here. Right. Let's go here. Right. So I'm talking about this one. You have your server 1, server 2, server 3, all the instance 1, instance 2, instance 3, all these instances are accessing the common database, which is shared. Right. So that's my shared storage here. This is my shared storage, which is attached to my both the nodes, and my database is residing under this shared storage. So this database is having these two instances running under this server. Any user who is connected to node 1, they can access the same database via this instance. Any user who connected to node 2 with that DevDB instance 2, they can able to access the same common database, which is shared under common storage here. Right. So with that, now this is simple understanding. If you look at this one, this is all about your rack. Rack means only this much of his setup. But it is not that simple to do this setup. Why? Because we have a couple of things. One thing, let's talk about here green color. Let's put it here. Okay. Let's take this one. Give me a second. What I'll do now? No, let's go here. Sorry, what I'm trying to do. Okay. Okay. I have this green color, and assume your green color is your public network. And then I'll put it as a red color. Red color is your private network. So these are the two types of network we use it in the rack: public network and private network. Public network is kind of, you can access these servers, these databases outside of your network. For example, it is your entire network. It may be your Infosys. You're working on Infosys, your Infosys network, or you might be working on your Wipro. So it's your Wipro network, or it may be working on Oracle. It's your Oracle domain. So outside of our Oracle domain, if anyone can able to access your servers or database, that's called a public network. And private network is within your network. Only those servers are accessible. Outside of network, they will not be able to access. That's your private network. These are the two network we're going to use it for any rack setup, public and private. Public is one, those IPs or those servers can be accessed outside of your network. And private network are the one which you cannot access using those IPs outside of your network. Right, those things. And now let's see, these are your servers, server 1, server 2. So what I say, this server 1 has a physical IP, So I'll put it with the green color. Physical IPs are in your public network. Physical IP. So your IP, I can give you 192.168.1.100 or 102. So let's say node to VIP. So node to VIP again, I can give 192.168.1.104. So I'll just same thing. I can put it on the node 1 as well. So 101, 103. So let's take put it. Okay, so these are my two IPs. What I mentioned here, this is my server. Node 1, this is my node 1, server 1, Linux server 1 and Linux server 2. These two server has a physical IPs 192.168.1.101, 1.102. These are the two physical IPs for these two servers. And these two server has a node VIPs. So there's a typo here. It's a node 1. Okay, let's remove this one. I'll type it one more time. So my physical IP for this server is 192.168.1.101 and node 1 VIP. This is node 1 VIP 192.168.1.103. Right. So these are my two IPs which are in physical network. So assuming that you have, let's put that you have your domain, like I can take this one. Right. So this is your entire infrastructure or entire domain. Let's say right, so I can put like this. Only I can make it black color. Okay, this is your organization. This is your network. I can say this is your overall network. It may be any domain. It may be wipro.com or infosys.com, oracle.com, or any organization, their network. And in that we have these public IPs and private IPs. Your both the server has a physical IP and has a VIP. Physical IP and VIP both are your public IPs. So we got two IPs right now, physical IP and VIP. So node 1 has a physical IP, node 1 has a VIP. Node 2 also has a physical IP, node 2 also has a VIP. These both are your public IPs or public network. Right? And your VIP also in your public network. Right, that's one thing. I'm going to talk about that. What is your physical IP and what is your VIP? Why we need physical IP and why we need a VIP? Physical IPs are the IPs which are assigned on the interface. This node 1 has interface here, ETH 0, and this node has a interface again 0. You may have ETH 0, 1, 2, 3, 4. Any IPs attached to interface are called a physical IPs. And virtual IPs are not the physical IPs. Those are your, the name itself suggests virtual IP. That's not a physical IPs, which are like virtually available inside your network. And why we need them? Whenever there's a failover happens, automatically those IPs will be failover to other node. So for example, if any client is connected to node 1, he will connect using this virtual IP. So if this node goes down, this physical IP will go down, but this virtual IP will be still available because that's not a physical IP. That is a virtually hanging in your cluster. And this IP will fail over to this node. 103 IP will come here. And this particular client is able to connect directly here using that virtual IP. So that's called your failover. So failover is possible because of this VIPs. Because VIPs will never go down. when this particular node goes down. When the server goes down, server crash happens, only your physical IP will go down, because physical IPs are tagged to interface, and your VIPs will be hanging inside your cluster. They will never go down. So those VIPs will shift to any other cluster nodes. Because of the VIPs, we are able to do these failovers in your rack. Right. Now, again, as I said, your physical IPs are attached to interface. And if any IP is not attached to interface, that's a virtual IP. So if I can go to my server here, and if I do ifconfig, and these are my interfaces. Whatever you're seeing, ENS 192, that's your interface. And any IP attached to that is your physical IP. Remember here what I talked, any IP attached to your interface is called your physical IP. Your virtual IP will not be attached to interface. That's how you can identify whether it's a virtual or physical. If I do ifconfig here, I got one interface, ENS 192. I got this one interface. This is my node 1. Let's put it here, node 2. I have this node 1 and node 2. Right. In that, I have this 192 and IP is attached here. So what's the IP? This is the IP. And again, on node 2 also, if I can go here, ifconfig. So ENS 192, again, the IP is assigned over there. So this is my one interface. You might be having ETH0, ETH1, ETH2 like that. So based upon your server, it goes like that. So you got your ENS 192, that's your physical IP. So I can say this one is your physical IP. Right, so that's your physical IP. Now let's see where is VIPs. These VIPs, node VIPs, what I said, those are the one which are not connected to any interface. They will be like VLAN. They will be like pegging. These IPs are just pegging to that same physical IPs with a colon, 1, 2, 3, 4, 5 like that. Those are your VIPs. If I can go here on my server, this is my physical interface, and I got physical IP. And with the same interface 192, I have this colon 1, colon 2. I got these two IPs here. Whatever coming with this colon 1, colon 2 are your VIPs. I got two IPs here, two VIPs. I can put it them here. One, and this is your second. I don't know which one is my VIP here. If I can, okay, this is on node 2. Let's put it here. This is for node 2. I'll put it on node 2. And for the node 1, 192 is my interface. This is my physical IP. For this 192 interface, I have colon 1, colon 2, colon 5. I got three IPs here, three VIPs. 1, 2, and 3. I got three VIPs. Let's put them here. I don't know which one is my actual node VIP. I need to get node VIP. So second is node VIP, right? Your node 1 VIP, node 2 VIP. I need to get the VIPs. So in fact, these 3 plus 2, all 5 are VIPs. And then out of these 5 VIPs, only 2 of them are your node VIPs. Now we got to know my VIPs. These are my VIPs. Out of these 5 VIPs, only 2 are like node specific, and remaining 3 I don't know. I can identify later. Okay, now we got all the VIPs. Right, go back here. We got physical IPs, we got the VIPs. And now again, simple way to understand, physical IPs tagged to your interface. Your VIPs are just hanging with that interface. Give me 1 second here. Okay, right. Sorry for that. So now we got physical IPs and VIPs we identified on the server. Next comes your private IP. The private IP are in a private network. The private IPs are in private network. Your physical IPs and the private IPs, these both the IPs are your physical IPs. Remember this one. What I can say here, your physical IP and private IP, I'll put down here. Physical IP, private IP, these two are your, the name itself suggests physical IP and private IP are your permanent IPs tagged to your interface. These two, one is on public network, one is on private network, both are tagged to interface. So remember these things. Both your physical IP and private IPs are tagged to interface. Those are like permanent IPs, the physical IPs. And one is in public network and one is in private network. And one is accessible outside of network because that's a public, and one is accessible within the network, that's a private. So again, if I can go back here, this node one, so I'll put it with the red color. Go here, red color. Node one, private IP. So 192.168.2.101. Node 2, private IP 2.102. So remember here, how I can identify public and private. Private is a internal inside your network. And by looking at your range here, IP range, you can easily identify. So this private IP start with the 2 dot series here, and private IP again to start with the 2 dot series, and your public IP start with this 1 dot series. By looking at this IP range, and you can easily get to know that which is in public network and which is in a private network. So these two are like physical IPs and the private IPs, physical IPs and the private IPs. These physical IPs are node specific IPs tagged to a particular interface. These physical IPs are tagged with this interface. These physical IPs are tagged with this interface, and you will be having your one more interface, ETH2 or ETH1. Let's put it here. You might be having your ETH1 because 0 is done here. You might be having your ETH1. So these, your private IPs are tagged to this particular interface, right? So your physical IPs and private IPs are the one physically attached to an interface. And those are the one will be accessible outside of your network because that's in a public network. One is accessible within your network. That's your private network. Right, so let's go back to my server. And if I can just do a node one, again, IF config, I got this physical IP and tagged with 1, 2, 3 VIPs. And again, further go down, I have one more interface and I have one more IP address here. Let's take this interface. Right, this interface and this is the IP. And again, on node 2, public IP attached here. And for that public IP, I got these 2 VIPs and followed by one more interface here. And with that interface, I can say this public, this private IP here. And the moment I get to know these two, I can easily identify this is my private network because I can see this is started with a 9 dot. My public is started with 4 dot series and it started with 9 dot series. So this is my private network. So I can say node 1 private network. And this is my node 2 private network. Right, so we identified now. So for my rack setup, what I need one physical IP. For 2 node rack setup, I need physical IP, 2 physical IPs. I need 2 VIPs and I need 2 private IPs. So 6 IPs, I need it. So I identified 2 physical IPs for the node, 2 private IPs for the node, and then I need only 2 VIPs, but there are 3 more IPs are extra. So again, these are VIPs. These 3 IPs are needed for your scan connections. We have something called a scan VIP. I can say scan IP. Some people will call it a scan IP, or some people will call it a scan VIP. Both are same. Your scan is always on virtual, not a physical. Right, so I can put it because this is a public network. Why it's not coming? Okay. Wait a second. Scan IP or scan, you can call it as a scan VIP. So now scan IP and scan VIPs. I can say 192.168.1. My public IP scan is also in public IP range. I got 101, 102, 103, 104, and I can follow with the same series 105, and then let's copy, paste here, and I can say 105, 106, and 107. So now I got to know these are my 3 scan IPs. I'll put it in the column here. Right. So these are my 3 scan IPs. So scan VIPs. By looking at this server here, ENS 192, 182, 183, these are my 2 physical IPs, and 182, 183, followed by 190, 191, and 192, 193, and 182. So these 5 are your VIPs, but I don't know which are my node specific VIPs or which are my node specific uh, scan VIPs. So here 1 VIP, second VIP, and 3 VIP, all together 5 VIPs. So you don't know which are your node specific IPs or node specific VIPs. So you need to look for something called NS lookup and then get it out. So if I can do here one of the IP, probably it might not work here. Let's see. Okay, it'll not work here. So in the real-time world, in the customer environment, the moment you do NS lookup of any of these 5 IPs, whatever you got, and you usually identify, you'll get the host name. So node 1, this is your node specific VIP. I can say node 1 hyphen VIP. And the other one is your 192. So you're going to see your node 2 VIPs. So you got your node 1 and node 2 VIPs, and remaining 3 are your scan IPs. The moment you do NS lookup, and you will be having your remaining these 5 IPs are your scan 1. Scan VIP, or you can say scan IP. So
Yeah, Malik,
the moment
that particular IP is on different subnet, right? So is that possible? That the second IP there, 138.9 dot.
no, that IP I need to change it. This is my old lab server. It should be a same network. It should not be a different network.
It's coming in both the private network and the scan network. It's a typo actually while copy paste.
1.4. Okay, it's a private network. Yeah, that's a typo. And we have these 5 IPs, 4 dot, 4 dot, and then 4 dot, 4 dot, and 4 dot. There's nothing for 5 dot. Yeah. So your scan and yours once again, these are the 5 things. Your scan IPs and physical IPs and node VIPs, all 3 are in your public network. Your physical IP, your VIP, and your scan. Scan again comes under this VIP. This VIP has a node VIP and the scan VIP. Both will come under your public network. And the private IPs are the one which will come under private network. And again, those will be tagged with a separate interface. Right. So by looking at my server, now I got to know what are my physical IPs, what are my private IPs, and what are my scan IPs. Once you are able to identify all these three things in your network, and this is your bare minimal requirement for the networking side. You have to work with your networking side and you have to tell them, okay, I'm setting up 2-node RAC cluster, node 1 and node 2, 2-node RAC cluster. I need a minimum of interface 1, interface 2. I need a 2 interface for one is for my physical IPs, one is for my private IPs. I need a minimum 2 interfaces to tag this physical IPs. One is node specific physical IP, one is a node private IPs. And 4 IPs I need it: physical IP, private IP, physical IP, private IP, tagged to the 2 interfaces. And followed by, I need a node specific VIP for 2 node specific VIP for both the nodes. And I need a minimum of 3 scan IPs. Altogether, I need 3 plus 3 plus 3, 9 IPs. Out of that 9 IPs, and 2 of them are private IPs, and 2 of them are the physical IPs. Both the private IP and physical IPs are tagged to your interfaces. Minimum of 2 interfaces, you need it on both the server. And I need 3 plus 2, 5 VIPs. So these VIPs and the scan IPs and the private IPs, everything will be defined on your DNS server with the help of your network team. So you have to work with the network and you have to put down your requirement. And he is the one who can configure all this network and he can provide these IPs. Right. Any questions so far on the networking part here?
Yeah, hi Malik. You told physical IP and private IP is a permanent IP. What about VIP? Is it constantly will change?
No, it will never change. Once you
Okay,
define, these are
yeah.
like permanent IPs in your network.
Okay, and can you explain about scan IP working functionality? Once, why? What is the behind?
Again,
that,
we'll talk about that later, or not at this point, because that's a different concept. We'll talk on that.
Yeah, okay. And if I want to create a 4-node cluster, total how many IPs required, Malik?
If you want to add one more node and you just need a 3 IPs, you need a third node, you need a 3 IPs. You need to add 4 node, again you need a 3 IPs for that node. Your scan is constant. You're not going to reduce or you're not going to decrease. The 3 is a best practice, or a minimum you need a 3. Even if you go with a 1 or 2 also possible, but minimum you need a 3 scan. And it's all about how many nodes you have it. Per node, you need a 3 IPs. You need a third node, 3 more IPs. You need a 4 node, again 3 more IPs.
Okay. Yeah, thank you.
Right. Right. So now that's about your networking setup. In order to build your 2-node rack, you need these many 9 IPs. You need to 3-node rack, 3 more IPs. You need to 4-node rack, another 3 more IPs. Because each node has a physical VIP, node VIP, and node private IP. 3 IPs for each node. That's a mandatory. Now, any clients want to connect to my database. Let's say my client 1, client 2, client 3, client 4. I can say client 1, client 2, client 3, client 4, anyone, like they're trying to connect to my rack. So just connect to first scan. Each connections first will go to scan. Scan has a built-in brilliant functionality. It's gonna reroute the connection based upon the node. So once a client connect to my, all these clients are connected to my scan, the scan will reroute. Okay, client 1, go to node 1. Client 2, go to node 2. Again, client 3, go to node 1. Client 4, go to node 4. Equally, like based upon the load, it's going to distribute all the incoming connections. These clients may be connected using a mobile or browser or web URL or any desktop client or any client or any software. They will connect to my database. First, they will connect to scan. Scan is intelligently reroute those connection to whichever the node having a less load or less connections. Right. Once they connect, your load will be distributed based upon your how these particular cluster nodes are behaving or cluster nodes are having it. So once they connect this one, that is a built-in functionality for scan to take care of that load balancing. If they connect this particular client 1, this is C1 and this is your C2, and this is your C3, and this is your C4. From the scan, your C1 connections will go to VIP. From the node VIP, connection will go to node 1. So assume why your scan will pass the connection to node VIP. Why your scan will not pass the connection to physical IP. As I said, physical IPs are the permanent IPs tagged to interface. And the node IP, node VIPs are the one like virtual IPs, not a physical IPs. Those are pegged to any interface with the :1, :2, :3. The client 1 connected to node 1 via this node VIP. This node 1 goes down. The moment node 1 goes down, your physical IP will go down because that is tagged to a interface. Your virtual IP will go down because that is also tagged to interface. But your node VIP will never go down. This node VIP will automatically shift over here on the any other cluster node. The 103, this IP will come here. So this IP automatically comes here. Whatever this client 1 who connected via scan to this node VIP to my node 1, automatically that client 1 connections comes over here. So that is the basic reason why client has to connect using a scan IPs, because scan internally pass that connection to that node specific VIPs. The moment node goes down, your VIP will fail over to any other cluster node. Since the VIP will fail over to any other cluster nodes, and automatically that client connection will fail over to that existing node. So make sure that all your clients are connected using a scan. If they're connected using your physical IPs, you will not be able to get the failover. If the client 1 is connected using a physical IP to node 1, if this node goes down, this physical IP will go down and this client connection will be broken. So always make sure that the end user is going to use your scan in order to achieve this failover. Right. Let's get the architecture part here. Right. Whatever we talked so far, all are mentioned over here. I have node 1, node 2, node 3, node 4. 4-node cluster. I have a node of physical IPs for all those 4 nodes. 101, 102, 103, 104. 4 physical IPs. Each of these 4 node has its node 1 VIP, node 2 VIP, node 3 VIP, node 4 VIP. 104, 105, 106, 107, 108. Again, your node IPs and VIPs are in a public network, green color, whatever I showed here. This your physical IPs, node IPs, which are in green color, public IPs, right? Well and good. So,
can I ask one question?
Yeah, please. Yeah, go ahead.
Where we will define the script to what we will give into the client machines means those clients which are connected to the RAC
Scan name.
They will have the host name of the scan IP only.
Yes.
And it will resolve automatically to one of them that we specified in 3 sets of IPs.
Right. That's correct.
So where this set will be defined?
Defined by your network.
Level?
That will be defined by your network engineer on the DNS domain side.
DNS domain side. Okay. So there will be one DNS entry, and against that particular DNS entry, we have 3 IPs. Right. Am I right?
Right. That's correct.
Okay.
All right.
So it's all dependent on the network DNS, which network team will define. Okay.
Right. Your network admin will set up that.
Like one more question.
So we never communicate the IP. We never communicate IP.
No.
Physical IP to the client.
No. I think you have some network issue. I cannot. Your voice is dropping in between. Please go on a mute.
We only communicate the DNS name of IP. Yeah? Okay. Okay.
Malik, I have a question. Could you go back to the paint screen? Here the client one connected to the node one, and since once the node gets crashed, suppose if the client one is executing the select command and the node one gets crashed, and then it will be automatically switched over to fail over to the node 2, and then it will start resuming that select command. My understanding is right?
Right. That's correct.
Okay, and then after that, the client 2 comes in to the scan VIP, and then suppose if there a chance that it can go to the same node 103 VIP, which is now running in the node 2.
Yeah, obviously the connection all will go to node 2. It will never go to node 1 again because
Okay,
you already
okay.
VIPs are filled over.
Okay, that VIP can get connected one more time, or 104 it will route it to 104 only.
104, like whatever the VIPs are failed over here, no new incoming connection in that IP. All the connection will go to 104.
Okay, okay. So the existing connections only will get switched failed over to the node 2, whereas the new connections will not access the same 103 node VIP.
Right. That's
Okay,
correct.
thanks.
Malik, I see some of the users using in connection string using IP address. So which IP I want to use here?
You should not use IPs. You should use a scan name. That's what I'm explaining here. You have this 3 IPs here right now on each of these node. Your node 1, node 2, node 3, node 4. You have 101, 102, 103, 104, 4 physical IPs. And you have node 1 VIP, node 2 VIP, node 3 VIP, node 4 VIP, 105, 106, 107, 108. Again, a public network. Those are the VIPs for your 4 nodes. And you have the 2 dot series. If you observe here, it's a 2 dot series. It's a 1 dot series is a public network. 2 dot series is your private network. You have node 1, node 2, node 3, node 4. All the 4 node has a public, private network here, which is in red color. Right. So your end user can connect to using mobile device, URL or internet or desktop. And once they connect, they will be having only TNS entry, this much of TNS entry. And if I can put it down here, this TNS entry has only your scan, just a scan name. This scan name will be internally resolved using these 3 IPs. 103, 102. Right. So these are the 3 scan. Your client will use a host name. He will not use the IP address. If you use IP address 1 IP, and always connection will go to this 1 IP. So instead of this 1 IP, we need to communicate with the scan. You need to use the database name with the host name. Host name should be your scan name. The scan internally reroute any one of these IPs. So we need to make sure that ask your client to use a host name. That host name is your scan name. Instead of if you put 1 IP here, like 193, that also will work, but that's not a best practice. If that IP goes down, if that IP is not available, client will not be able to connect to your database. Right. So if we use like this IP, one of the scan IP, still connection works as long as this IP is available. If this IP is down or if it IP is not available, you'll not be able to connect. Instead of that, if he uses this scan name, if he uses scan name here, the client try to connect with 1 IP. If this IP is not available, it will go to second IP. If that available, it will go to next IP. He has a high availability here for the connection time. Any one of the IPs will get assigned to him if he uses a host name. Host name means it's a scan name. Right. So any client connect via mobile, URL or internet or desktop, he has to give a TNS name with the scan name. Make sure that you provide a scan name. It may be your application server, or it may be your mobile XTerm, or it may be your SQL developer, or it may be your Toad, or whatever you are connecting. Use a scan name so that you will be having that high availability feature. And once the client connects using the scan name, they uses the scan name. And with the scan name, this is your scan name, TNS name. And the scan name has a 3 IPs, 200, 300, 400. I just given rough 192, 168, 1.200, 1.300, 1.400 for 3 IPs. And with that, client 1 connection will go to node 1. That will be with the node 1 VIP, not a node 1 physical IP. Node 1 VIP, he's going to access my database. And assuming that this particular node 1 goes down, node 1 goes down in the sense your physical IP will be down, because that physical IP is attached to your interface. Interface will be down. And this particular node 1 VIP will be like hanging in your cluster. This is your entire cluster. It will be hanging here. And automatically this 105 node 1 VIP will fail over to either node 2 or node 3 based upon the load. Okay, your scan will handle that one. It will not fail over to any one of the node. So assuming that 105 is came here. If the client one, this is your client one connected here on this node 1, if node 1 goes down, automatically this client 1 will be connected over node 2 because 105 that VIP has failed over here. So because of the VIP, the failover is possible. If there is no VIP, then the failover was not possible. And once the client is connected over here on the node 2, and whatever the select query he was running, is fetching 1 million record select query. Out of that 5 million record came, and another 0.5 million record came, another 0.5 million record yet to come, and will continue from the where that query was stopped. And once after it fail over, it's gonna pause it from that where it has left out. And in case of RAC, only select queries are failed over. And if this guy's client 1 is doing insert, that query, the moment his session will fail over to node 2, the insert query will be rolled back. You have to resubmit that insert again. Whatever insert, update, delete, whatever the DML operations, the client has to resubmit it. Only select queries are supported in case of RAC. Whenever the failure happens, whatever the select query, wherever it failed, you'll want to continue from there. If it's an insert, update, delete, or any DML or DDL operation, the client has to resubmit that query. The moment the failure happens, automatically internally database or Oracle will roll back all those transactions, insert, update, delete, or the DML or DDL statement. Right. So that's about your RAC networking and the RAC fundamental, how the scan through VIP is going to connect to my database. And if somebody asked why scan, scan is for load balancing. The moment client comes, automatically your scan aware of out of these 4 nodes, which one is the least load and route that connection to that particular node. Scan is for high availability and the load balancing. And if somebody asked why VIPs, VIPs for your failover. If you don't have a VIPs, your scan will pass the connection to your node IPs. And via node IPs, your connection will go to database. If that particular node goes down, your node IP will go down and the failover is not possible. Right? If somebody asked what is scan, scan is for high availability and the load balancing. Why VIP? VIP is for in order to achieve your load balancing. Sorry, in order to achieve your failover, we have something called TFA, transparent application failover or just failover. That's possible only with the VIPs. Otherwise, it's not possible. Right. And if somebody asked what is the use of private IP? Private IP used for your inter-node communication. What is inter-node communication? So that's one of the common questions. Why you need a private IPs? Private IPs for inter-node communication or inter-node data transfer. We call it as a cache fusion. What is cache fusion? One of the common entry question. What is cache fusion? So what is cache fusion? So your private IP will come into picture for cache fusion and for node communication. So these are the 2 important things. Node to node communication and the cache fusion will be happened in your private network. First understand what is node to node communication. So node 1 will ping node 2. I'm able to ping you, and node 2 will send a response back. Okay, I'm also able to ping you. That's node to node communication. Once the node 1 and node 2 are able to communicate each other, so your cluster will mark both the node 1 and node 2 are available inside your cluster. Again, node 1 to node 3 will ping, and node 3 will ping node 1. Again, node 1, 2, 3 are available inside my cluster. So between the node 1 and 2, all the communication will happen with this private network. So we don't want to trouble that end user network. End user network is your public network. If this node to node communication, the ping is going to happen with that public network, that's going to put a load on your end user connections, right? So just to avoid that, this private network came into picture, just to avoid that traffic for the node communication. That's one thing. And the second other major advantages for your private network is your cache fusion. Again, one of the common interview question, what is cache fusion? So your client 1 connected to node 1 and he did a select statement on the table T1. And the table T1 brought here This is your instance. Again, instance is what we talked about. Again, basics of instance. Your instance is nothing but memory plus your background process. So in this memory, you have your buffer cache, you have your log buffer cache, your Java pool, large pool, seed pool. Your buffer cache is the one, whatever this table T1 he selected, the table T1 is kept under this memory here, right? And then client 2 connected to node 2, and he's trying to access same. This client 1 is accessing table T1. Client 2 connected to node 2, he is accessing the same table T1. And this client 2 from this instance 2, here we don't have a table because this buffer cache is empty. So if this client 2 goes to database and get the same table and write it into buffer cache, from then it's going to get it to user 2. That is very expensive because from the buffer cache, from the memory to access your database, it has to go through your IO, disk IO. The disk IOs are too expensive, means too costly. It means like time consuming. So why this client 2 has to go to your, sorry for that, somebody is writing. So why this client 2 has to go to disk to access the table T1? The client 2 will simply ask your instance 1, do you have a table T1? The instance 1 will say, yeah, I already have the table T1. Let me send those table T1. So already data will be sent from this memory to this memory, this buffer cache to this buffer cache. Data will be sent here and automatically data will be read. So we all aware that transferring the data from memory to memory is always much more faster and easier. Accessing anything from the memory is easy and faster, and the data will be the whatever the table T1 will comes here, and the client will easily get the data. That's called your cache fusion. Cache fusion is nothing but the transferring your data blocks from memory to memory, from one buffer cache to other buffer cache.
So Malik,
Right.
is there any need to install a high-speed interconnect between node to node in order to faster transfer of in case of cache fusion,
Right.
or the simple Ethernet card is sufficient? What you
Both.
suggest?
It's all left to you. How much data you are reading, how many transactions, whether it's OL AP or OLTP, and that all matters. And it's
Okay.
recommended to always have a high speed of internet. Whatever your public network 10 gig, go with the private network also 10 gig.
Okay.
Right.
Right.
So that cache fusion happens through the data blocks will be transferred from one node memory to another node memory through private IP, right?
Right. That's correct. So if it uses the public network, they're going to hinder your end user connection. So we don't want that end user network connection to hinder end user connection to be free, and then so that I can do all this cache fusion, node communication, all the disk communication via my private network. That's the use of your private interconnects. Right.
Okay.
With that, since we're talking about this cache fusion and all, one more concept, we call it as a master node. Master node means, right, so client 2 connected to node 2, how this client 2 aware that table T1 is available in instance 1. First, it may ask instance 3, right? And instance 3 will say, I don't have that table T1. Later, instance 2 will ask instance 4, node 4, do you have table T1? Again, node 4 will say, I don't have the table T1. Later, it will ask for instance 1, do you have that table T1? Yes, I have the table T1, and instance 1 will send that one. So it is unnecessarily doing some 2 calls, right? Instance 3 and instance 4, it is doing a 2 calls and waiting for the response. And third call, it is doing for instance 1, and it got the result. So it's unnecessary, expenses. It in order to get the table T1, it has made 1, 2, 3 calls. So how I can avoid that? In case of 4 node cluster, in case of 8 node cluster, or in case of 20 node cluster, the maximum probability to do is 20 calls, right? So that is a bad design. How to handle that one? For that, Oracle has internal mechanism called master node. Master node means any one of the cluster node will be master node. For example, node 4 is a master node. Node 4 will manage something called GRD. So global resource directory. It will maintain the table called GRD, node 4. Node 4 is the master node. Node 4 is marked as a master node. So this node 4 will have that all the information. Okay, instance 1, has a block called table T1, and instance 2 has a block called table T2, and instance 3 has a employee table, and instance 4 has a department table. All the buffer cache information will be available in this GRD table, and that will be available in the master node. So this particular client 2 will connect to node 2 and directly, without requesting for node 1 or node 3, directly it's going to reach out to master node. Okay, I need table T1. Do you have that information? Your master node will immediately check for the GRD table. Okay, table T1 is available on the instance 1. Go ahead and fetch that one. Immediately your instance 2 will go to your node 1 and get that table T1 information and then get it back. So this is called your, it has first made your GRD table here, like, your instance 2 to your GRD table as a master table. From the master table, it has got a response. From that response, it has went to your node 1. That's a 3-way GC buffer. We can call it as something wait event in the cluster. It has done the 3 calls. Like one is from instance 2 to master, from master to node back, and from the node to instance 1. It made a 3-way. It's a 3-way wait event. And the same thing goes if client 3 connected to node 4, and that node 4 is master itself. It is again selecting the same T1 table, and now client 4, like whatever the client 3 connected to node 4, the node 4 itself is a master table. It will not request, it will directly read the GRD table. Okay, table T1 is available on node 1, and automatically it's gonna go to node 1. So one is connection to node. From that, it's gonna go to node 1 and you'll get the response. It's called a 2-way GC wait events. So in the RAC, we have a 2-way, 3-way GC wait event based upon where are your data blocks, and from how you're gonna fetching the master node, from the master node, how you're gonna getting the data. That all depend upon your master node and the GRD table, right? So that's again
Malik,
internal
one
to.
question.
Yeah.
Malik, one question. The instance 2 got the data from instance 1 by asking the master node. Now, in this scenario, both the instance 1 and instance 2 are having the T1 table data. Now, the next client 3, when it comes,
No.
which
It's going to
one
transfer the data. It's going to
which
transfer
one
the
will be
data.
considered as?
It's going
My
to
question
transfer
is,
the data. Once again, it's going to transfer the data. Once the
okay.
node 1, node 2 request the data, from the node 1, data will go to node 2, and the data will be removed from this particular node 1. It's not going to keep that same data on all the buffers.
Okay.
It's a redundant
Okay.
data.
So then the GRD will be updated saying that now the table 1 is located in instance 2.
Right.
Okay.
Right. So that's about your failover and the cache fusion and the why we need a private network. We talked about this, why we need a scan, why we need a VIP, and why we need a the private network. So with the help of that, let's understand 2 more concepts in details. Let's go here.
So Malik, GRD is a internal virtual table, resides in memory, or it's a physical table?
It's a physical table. Right. Now let's understand, we already talked why scan, and we talked about why VIP, why your private IP. So now we got to know the private IP is for cache fusion and then node communication, or you can say intercommunication. Right. So internally node to node communication or the cache fusion, transferring the blocks, your private network is mandatory. That's a much more faster. And physical IP. So physical IP is a node specific IP. Any particular server, it should have its own physical IP. Without physical IP, nobody can able to access that server. Why physical IP? That's a built-in functionality of your Linux server. right? In this type here, the physical IP is nowhere used in my cluster, apart from that tagging to that particular interface. Each and every server should have its own physical IP in order to access that server. The physical IP is not used much. The physical IP is like node IP and which will be accessed, right? So that is not gives much importance in my cluster setup, but that's a mandatory. That's the Linux basics. In order to run any Linux server, it should have an interface, and that interface tagged with a particular physical IP so that that can be accessed by any of the outside world. So physical IP will be available. And if I can see my RAC database, I can give like this. My physical IP 192.168.1.101. My RAC instance one, so I can say devdb1, devdb1. So devdb2, I can say 102. So these are my two physical IPs, right? Like 101 and 102. So I have these two physical IPs, and I can use like this. devdb1, devdb2, pointing to 101 and 102. I can give to my client this instance 1 and instance 2. Any client who connects using like this, they can directly connect to instance 1. They can directly connect to instance 2. If 10 user connected to node 1 and 1 user connected to node 2, right? Because we don't have a particular load balance here. If 100 user connect using this node 1 will be having 100 connections. Only 10 user connected using this one, only 10 connections will be on node 2. The drawback with this physical IP is like no load balancing, first of all. And if the clients are connecting only node 1 will be overloaded. And the third drawback is if the node 1 fails, if the node 1 crashes, no failure here, because the physical IP itself will go down and all the client connection will be terminated here. That's one of the drawback. Still, this connections works. You can use it. Now let's come. Oracle came up with the VIP in I think 10G onwards. In 10G, they came up with this, the VIP concept. Just to provide this, the failure scenario, how to avoid the failure scenario. So they came up with the this VIP concept here. The same thing, right? Let's go here. Instead of 101, 102, use 103 and 104. Still this connection works. You client able to connect to my database, right? 103 is here, 103, 104. Client can directly connect to database using this VIP, right? If the client 100 client connects, they all connected to node 1. If 100 client connect using this node 2, they all connected to node 2. If 100 clients are connected to node 1 using this one, and only 10 connections are connected to node 2 using this one. So again, there's no proper load balancing here. But however, 100 clients are connected to node 1. If the node 1 goes down, this VIP will fail over to other node and all the connections will be achieved. We are able to achieve the failover, but we'll not be able to do this proper load balancing. And for that, what Oracle has done, they given some manual workaround. What is that manual workaround? So manually put your all the client details into your scan. So into your TNS name, all the VIPs, so that we can manually, load balance it. How? Like this, something like this. I can put it over here. Instead of giving node 1, node 2 specific, use like this. Host 1 VIP, host 2 VIP, host 3 VIP, and whatever the port. So again, instead of host 1, host 2, I can put like this VIPs here. Right, it's a 4. So with the help of this node instance 1, instance 2 specific connection using this VIPs, we are able to achieve the failover. In case of node crashes, the failover will be possible, but the proper load balancing is not available here. Then what you will do? So something Oracle suggested to use like this. devdb and use your service name, not a DB name, service name and dev DB. Let's put it over here. Right. So use something like this. What happens here? We are able to achieve the load fail over here using this one. Automatically 100 user connected here, only 10 user connected here. The moment node 1 goes down, all the 100 user goes to node 2 because we're using the VIP connections. But failover is available, but the load balancing was not there. Oracle recommended to use load underscore balance equal to S. And is this literally doing a load balancing? Yes, it is doing a load balancing in a round robin fashion. What that mean? Client 1 comes, go to node 1. The load balance equal to S means client 1 connects using this, both the names here, load balance equal to S, go to node 1. Client 2 comes, go to node 2. Client 3 comes, go to node 1. And client 4 comes, go to node 2. Like in a round robin fashion, we're going to keep on routing the connection, but it literally don't know how much load they're putting it. Assuming that client 5 comes here, by the time client 5 comes, what happens? Node 2, this client 2 has disconnected and this client 4 has disconnected. Now node 1 has 2 connections, node 2 has 0 connections. If the client 5 comes, and as per the round robin, node 1, node 2, node 1, node 2, again connection will go to node 1. The connection will go here. Even though node 2 is 0, the connection will not go to node 2. Connection will go to node 1. This is a manual effort. Manually, if you put load balance equal to S and mention both the nodes, node VIPs, your connections will be round robin. I don't know whether the clients are connected or clients are doing the transactions. It doesn't matter for me. I'll be keep on routing the connections in a round robin fashion. So that is not the ideal way of load balancing. That's the other drawback. Whatever this Oracle suggested in 10G, that did not work out. And then how we can avoid this one? How we can, that's one of the drawback. And the second drawback is right now I have these 2 nodes. Later, over a period of time, my business is increasing and I have added 2 more RAC nodes. Right now it is only 2 node RAC. I have added 2 more RAC nodes and I need to inform all the clients who are using these TNS connections. It may be 100 user, 1000 user, 10,000 user or 1 million user. I need to communicate all the 1 million user. Okay, guys, go ahead and then change your TNS name and put these 2 entries in your TNS entries. Like something they had to do it. They have to put like this, these 2 nodes. 2 node extra you added here. 105, 110. Right? Again, over the period of time, again, 2 more cluster node you add it. Again, you need to communicate to your client that, again, add these 2 more nodes. Or if you remove any of the cluster node, you need to go ahead and then communicate, okay, I removed my node 4. Can you guys remove it from your TNS names? That will become a tedious job, right? So it is not a enterprise business solution. And to avoid this overcome load balancing challenge, and whenever you add a cluster node, whenever you remove a cluster node, every time application team has to reconfigure their application. It's a complete downtime. All the end user has to manually edit the TNS details. Again, that's a manual effort. To avoid that, the scan came into picture for load balancing and node addition and deletion. So what we're doing in the scan, we're not giving anything specific to node. We're all giving everything at my scan name. If I can go here, where is that? Okay, if I can take the scan details here. So I'm just giving DB name, and here I'm just giving a scan name. I no need to give node 1 or node 2 or node 3 or node 4. I just give a scan name here and my DB name. Automatically scan will route the connection to whether to go to node 1 or go to node 2. I'll just give the scan name here. Scan will reroute all the connection to node 1 or node 2 or node 3 or node 4 based upon intelligent mechanism. So by using the scan, which came in your 11G release 2, With the help of the scan, we are able to handle load balancing, as well as whenever in future you're going to add the new node or delete the new node, doesn't matter here. You're using the scan. If you're running a 4-node rack today, over a period of time, you may run 8-node rack. You no need to inform any of the client, or you no need to application user, no need to rebuild their application, because they're all built with the scan name. Scan remains same. You can add a multiple nodes, you can drop a multiple node from your cluster. That will never hinder. So that's the reason scan plays very, very important role. Right. That's about your all the IPs, whatever we discussed. Public IPs, private IPs, VIPs, and the scan IPs. So by this time now you will be able to understand if somebody asked why we need a private IP, why we need a scan IP, why we need a scan, why we need a VIP, should be able to answer it. Right. Any questions, guys, so far on the architecture part?
Malik, it's all about, if you are talking about the scan, then it's Oracle RAC internal load balancing architecture. Okay, so it means there is no need to install an external load balancer.
No need.
So it's one of the benefit of Oracle RAC that it have its own built-in internal load balancer in terms of scan. Am I right?
Right. That's correct. Right. Let's go back here now. If no questions, that's about the RAC architecture or the networking. And let's quickly talk about two more things. Clusterware and ASM. So clusterware and ASM. What is clusterware and what is ASM and what is DB? So we have earlier in 10G and all, we used to have three software. One is your clusterware software. Like we used to install like U01 app clusterware. So we used to install clusterware software, and we used to install U01 app ASM, and we used to install U01. Let's put them here. U01 app and DB. So this is your node 1, and the same thing goes to your node 2 as well. So this is your node 2. So node 1, install your clusterware software, which will make both the node 1, node 2 combined together. It's a cluster, and then it's going to form your clusterware services. Later, you're going to install your ASM software on node 1 and node 2, where you're going to create ASM 1 and ASM 2 instance. Later, you're going to install your database softwares on node 1 and node 2, where you can create a database instance 1 and instance 2. So we used to install 3 softwares in order to do this cluster setup. But later, what Oracle has done, why to install multiple softwares? And your clusterware is to form a cluster, 2-node cluster, 3-node cluster. Your ASM is just to provide your ASM storage, right? ASM storage, or to store your data files, your CID files. And Oracle thought, okay, let's combine this both clusterware and ASM software together and make it as a GI, grid infrastructure. So they made it as a grid infrastructure. So now what we're doing, we're installing GI software followed by DB software. So the GI software will go like this: U01 app grid, and your DB software will go like the U01 app and your DB. So this grid software, if somebody asked what is grid infrastructure is a new software provided by Oracle by combining your ASM software and your clusterware software. Right, so your clusterware software and ASM software combined together, Oracle has given only one software that's called your grid infrastructure or the grid software. So right now we are installing only GI and the DB, so that we can able to set up this GI. The moment you install the grid infrastructure, they're gonna install your ASM instance, as well as they're gonna form a 2-node cluster. Right, in my setup here, so this is my grid. and this is my database software. So in this grid, I am running my plus ASM 1 and my Clusterware, both together combined here in one single software. If I can go here, ls-ltr or ls-l or ls. So this is your grid software, what you are seeing here on both the nodes. So if I can go on the same second node or ls, this is your grid software. And if I can go to my
So-
DB home, yeah, go
So
ahead.
Malik, we will install only on the one machine on one node all these software, and these software will automatically shift it to the other node, or
Right.
we need to install individually on each node.
That's possible. You can do it on individual node, or you can do it on one node, automatically copy it.
Okay.
In silent method, you want to go, you can manually copy it across all the node and do form a cluster. That's also possible. But ideally, best practice is to download the software in node 1 and run the run installer. That's a grid setup. The moment you run it, you'll wanna install it on node 1, automatically copy it on node 2, node 3, node 4. I will see it during the part of installation.
Okay, thank you.
Right. So that's a simple understanding. What is ASM? ASM is automatic storage management. In order to provide your shared storage communication, like node 1 and node 2, provide your shared storage, your ASM plays very, very important role. Your ASM is for providing your ASM storage. And your clusterware to form a 2-node cluster, 3-node cluster, all the cluster communication, all the cluster services will work across your cluster nodes. And your database software is for your database instance to run or database instance to operate. Your database instance is needed. Right. So that's a simple understanding between your clusterware and the ASM. Combining clusterware and ASM, Oracle has given a new naming convention. That's a grid infrastructure. And database software is obviously a software where your database instance will run. Right. That's a simple answer for that. And now why ASM and why database? In order to use your database on the ASM storage, so your ASM instance has to be up and running, right? So your ASM instance, why we need ASM instance here? Right now we are seeing ASM instance 1 here, ASM instance 2 here. Why we need this ASM instance? This ASM instance is needed in order to manage your storage. First thing is ASM storage. ASM storage, ASM is stands for automatic storage management. In order to manage the storage, your ASM is mandatory. That's one thing. And any clients who connected to my node 1, in order to access this ASM storage, your ASM will pass that connection to database. ASM will act as a client and your database instance. This client and database instance, whatever via this database instance, whatever that data they're accessing, your ASM will act as a mediator. Without ASM, if your ASM is down, your client will not be able to access the database. Will not be able to access the data from that ASM storage. Right, so your ASM is act as a mediator between the client and the database instance to access the data, and also your ASM instance will manage your ASM storage. Those are the two primary tasks for my ASM. Why ASM? ASM is having these two tasks: the mediator between your client and the database, and ASM is to manage your ASM storage. Right, that's where you need the ASM instance on each of those nodes. And your database instance, any client connected to database instance, via that database instance, they're able to access the database. Right. And furthermore, if we go, let's quickly go on a lab, quickly check it out. We talked about ASM, we talked about database instance. Let's check it out here. Grep SMON on node 1. So you have your ASM, you have your database instance, both the instance running with Oracle user. Sometimes you can see your ASM is running with the grid user. It all depends upon how you configure, how you can design your architecture. Right now I can say node 1 has instance 1 and instance 2. Node 1 has ASM instance 1 and ASM instance 2. Same thing goes on node 2 as well. ASF grep SMON, and this is my node 2. Right. So both ASM instance 1, ASM instance 2, database instance 1, database instance 2, both are available. As I said, ASM act as a mediator as well as it has its own storage. So in order to go to that ASM storage or in order to manage that ASM storage, you need to set the environment to plus ASM. So you need to first log into that respective owner. I log into that Oracle owner. I logged into Oracle owner. Oracle is owned by both ASM and database. Now I want to go to ASM storage. So let's go from node 1 or node 2, anywhere you can connect and operate it. Just run .env. What is SID? I want to connect to my plus ASM one. So once you connect ASM cmd-p, that's gonna go into your ASM command line. A list DZ, list disk group, that's gonna give you what are your current list disk group. LSDG. Again, we'll talk about what are these disk group, how you can create as part of our actual installation. So in order to manage your ASM storage, you need to go with ASM CMD. So that's your ASM command line. So that's going to take you into your ASM command line. And then you can manage your LS disk or LS disk group or whatever command, whatever the storage management you want to do it, you can do it. That is your ASM command line to manage your storage. And other way to manage your ASM is SQL plus /s sys ASM. You have to connect SQL plus /s sys ASM. That's gonna go into your ASM SQL command line. This is your ASM command line, and this SQL plus as sys ASM that's gonna take you to ASM SQL command line. So you can manage your disk group inside your command line. LSDG list disk group, you can get data, OCR and RICO. Similarly, you have inside a SQL command line $, ASM underscore disk group, select group number, comma, group name from $, ASM disk group. So that's going to tell you data, OCR and RICO, same thing, whatever you're seeing it over here. So you can manage your ASM and ASM storage from ASM command line or your ASM SQL command line, both should work. And the other way to manage your ASM is your CRSCTL or SRVCTL. If I do SRVCTL status and ASM. So this is at your OS level using SRVCTL. Your ASM instance is up and running on node 1 and node 2. And you can do SRVCTL config ASM. That's other way to manage your ASM, your ASM backup password file, your ASM password file, and your ASM listener and your cluster net listener. And yeah, that's about your managing your ASM with the OS command line using SRVCTL or your SQL command line by connecting SQL plus assist ASM by connecting to ASM command line, whichever you are comfortable based upon whatever the troubleshooting you are doing, you're going to deal with any one of this. Right, that's about ASM. And coming to cluster, so most of the time cluster operations or cluster troubleshooting, we use CRSCTL. If I can go back here, CRSCTL, stat, resource -t and -init. So these are your cluster daemons. So you have in order to form this 2-node cluster, we just say that install ASM and ASM software, it will form 2-node cluster. In order to form this cluster, in order to work this cluster without any issue, there are like hundreds of background processes, hundreds of daemons, hundreds of cluster services. Like few of them are your cluster interconnects, your CRF, CRSD, CSSD, CSSD monitor, CTSSD, disk mount, ACFS driver, EVMD, GIPCD, GPNPD, MDNSD, storage. These are your cluster services. We're going to talk in detail about what are these services, how these services are get started, and all those things. So that's your init daemon. You can see CRSCTL stat resource -t -init, which are services, which are cluster resources are up and running. And if I can go to other node here, plus ASM2, anything you want to do cluster level or ASM level operation, you have to set the environment to first. CRSCTL stat resource -t -init. So again, these are your cluster resource on the node 2. And if I remove this hyphen init, or like other way to monitor your cluster resources, ps-ef grep d.bin. These are your cluster daemons. Your OHSD, Vara agent, Vara root agent, MDNS, CVMD, GPNPD, and your GIPCD, CSSD monitor, OSIS monitor, agent. So these are your cluster resources. You can see ps-ef grep d.bin or crctl stat resource -init. So if you remove this hyphen init, it's gonna give you all the cluster wide across multiple node information, right? So you can see your listener up and running on both nodes, your database listener up and running, your CHAD, your net1 network, ONS, your ASM net listener, your data disk group, your scan listener, scan 1, scan 2, scan 3, your OCR disk group, record disk group, your ASM instance, your ASM net listener, your database status, and your database services, and your node 1, node 2 VIPs, and your scan 1, scan 2, scan 3 VIPs. All those will be available at cluster wide resource. And the same command, you can run it from any node, you're going to get the same result. Right. So we most often we use CRSCTL to deal with my cluster level resources, and sometimes we use SRVCTL as a other command line tool to manage your clusterware. Right. So that's about your clusterware and ASM. So both together works on the same location. That's your grid location. And based upon what troubleshooting we're doing, we're going to do that appropriate action on that. Right, that's about your clusterware and the ASM instances. And if you want to go for your database instances, so you have to again set the proper environment. Right now, I need to go for database instances. I need to first log into that respective owner and set the environment. .var-env plus devdb instance 1 env pipeline capital Vara. So that's going to tell you whether you set a proper environment or not. SQL plus /s sysdba. Remember, we want to connect to database. We'll connect as a sysdba. So that we're going to go to SQL command line of your database. Select name from $, database. So that's your devdb, the database. Select instance underscore name from $, instance. Select instance. So that's going to give you connected to instance 1 because I'm at node 1, instance 1, and accessing the same database. So you can use your SQL plus to connect your database, or there's a other command, srvctl status database -d and devdb. Right, you can start everything from SQL command line or srvctl. Both the way you can manage your database. And ASM also you can manage using srvctl or using SQL command line or using your ASM CMD command line. Any of these three methods you can manage your ASM instance. To cluster, sometimes most of the times 99% we use a CRCTL to deal with any of the cluster resources, and sometimes we deal with srvctl. Right. So that's all about the whatever we wanted to discuss for today's sessions. Provided if anyone has any questions or queries to talk or discuss, we will take it for another 10 minutes. Otherwise, we're good to stop it for today.
Yeah, hi Malik. SRVCTL and CRSCTL, which one owns those commands?
Both grid and your Oracle and root. There's nothing specific who owns it. Everyone can use that.
Okay, by Oracle user also we can like execute CRSCTL commands.
Right.
Okay. And for this scan listener, do you have any other class or else?
What scan listener?
No, actually, what is the logic behind that scan listener? So we have
That will be discussed in detail. That's the internal things. We cannot take it in 1 hour or 2 hours. That will be part of the course when we talk about in more details. So this is just a basics what everyone has to understand as part of this demo.
Okay, Malik.
Right.
Malik, Flex ASM also will it be covered in the course?
No. No. We'll give a basics about that. What is Flex ASM, how it works, but That's a mandatory starting with 19C.
Okay.
All right.
And the CDB is covering here, right? I mean,
Right.
like,
We already talked on that, right? That's a separate topics for CDBs and PDBs. And we'll be covering that chapter number 11. Where is that
Mr.
one?
Malik,
Chapter number 16. Yeah.
This is Sherjan from Kabul. Which operating system will we use for that one?
Which
Will
are?
be sent to operating system.
It's a Oracle Linux VL 7.9.
Okay. Could we use CentOS or Linux 7?
Both are same. Your
Okay.
CentOS, Linux, RHEL, Oracle Linux, Ubuntu, SUSE, all are same. Whatever we're doing it, it's the same command, no difference. So it's the same. Only it comes to your AIX when it comes to your HPUX, when it comes to Windows, those are the big gradient and some little different setup is needed. But otherwise your Ubuntu, SUSE, RHEL, Oracle Linux, all are same. You can use it any one of that.
And Malik, whenever you executed CRS-CTL status without init, there is some is showing offline. Is that like that only?
Yes, that's because of the Flex ASM. So Flex ASM expect minimum starting with the 19C onwards. We're going to talk a little bit about Flex ASM, what is it in as part of regular classes. Starting with 19C, Oracle came up with new concept, Flex ASM. Flex ASM needs a minimum of 3 ASM instance. 3 ASM instance. In order to install 3 ASM instance, you need a minimum of 3 nodes. Right. So right now we are having only 2 node instances. So that is 3 node is needed only for Flex. If you're using a Flex, you need a 3. And that's a default with the 19C. That's what it says. Your OCR, your instance 1, instance 2, and it is expecting a third instance, but we don't have a third instance. And same thing goes for your ASM. ASM, I have only ASM instance 1, ASM instance 2. I don't have ASM instance 3. So that is because of the Flex. Flex needs at least minimum 3 instances. So since we are doing only 2 node rack, so we have ASM 1 and 2. So 2 hours should be online. Third I can ignore it.
Yeah, got it, Malik. Thank you.
and
Malik, I'm using Windows, so will we install Linux VM?
Right. Same thing here, like my laptop also is Windows, whatever you're seeing here. We use something called VirtualBox, Oracle VirtualBox. In that VirtualBox, we're going to install 2 VMs, the Linux VMs. And then from there, we're going to set up RAC cluster. You're going to
Okay, so
install VM
Linux
1.
setup. Okay, so Linux setup will also be in the like course.
Right.
and
Right.
can we install the RAC built in cloud in AWS running here?
Yes, you
Instead
can
of
do
using
that.
our own laptops.
Yes, you can do that one if you provided you have a cloud access.
Okay. And other thing is, Malik, like nowadays most of the clients are moving to cloud, right? So, like, how about the future of the Oracle in going forward?
The even cloud, whatever cloud comes, DBA is a mandatory. So cloud will just to give you, the user experience, like creating databases, creating instances, spinning up your whatever the servers. It will be like UI based. But once your database is ready, so there should be a DBA to manage your database. Any request comes, create user inside database, or the check the permissions, check the privileges, or create a table space, or do whatever administrative activities. DBAs are mandatory, right? So whatever cloud it is, DBA jobs are always there, right? Any more questions, guys, before we stop it for today about the course of the course?
Mr. Malik, it's not a part of this course. I'm asking regarding the DBA classes. It will start on 14. It will be on the same time.
No, DBA is a separate. The RAC is a weekend batch, Saturday, Sunday. Database is a weekdays batch, Monday to Friday. That's
No, it will be on the from 9 to 10. Sorry, from 9 to 11.
Yep, that's correct.
Okay. Okay. Thank you.
All right, so yeah, before we stop it, couple of questions in the chat. Flex ASM, yes, we'll cover the basics, but we'll not go deep dive on that. And there's other questions, how scan IPs are defined for the trees. Again, is in your, will be part of our cluster, part of our installation. We do from the scratch. We do like how we can set up a scan in the DNS and all will be covered here. Don't worry, it's a part of, again, it's a network guy, network engineer who has to do this one, setting up of your VIPs, scan IPs, physical IPs in the DNS. But since we are doing our own setup in our own lab, we're doing all this DNS, scan, VIPs, everything by our own. We're going to show you all the demo on that. And all the name resolution, everything will be like set up by our own. Again, it's literally not a job of DBS. When you're working on the real-time client environment, your network guy will do that one. Right. One more question, how many max nodes we can have it? I'm not sure, like I never thought of that, but I see in my career, I worked on the RAC cluster of 64 nodes for one of the client. That's the maximum cluster nodes I worked, 64. But limit, now maximum number of limit, even I'm not sure at this point of time. Local machine, okay, all these IPs will be defined in our local machine. Yes, so again, as I said, all these IPs, we are going to set up our own DNS server. All the IPs are going to be defined in the DNS server, and via DNS server, we're going to resolve all these IPs. And why 3 scans? Yeah, it's again, there's no hard and fast rule. You can have one scan IP, 2 scan IPs, or 3 scan IP, 5 scan IPs, 10, 20, 30. It's all depending upon you. But minimum 3 is the best practices. Even with the 1, you can go with that. But as I already told you, if that IP is not available, your scan will be goes down. So 3 is the default one. So go with that one. And again, we covered what is scan, what is VIP. And interface 224 is also physical interface. Yes, any interface you see, I have config in your server, whatever the interface you see, all those are physical interface. All right, so I think I answered all of those questions. Right, guys. So if no more questions, good to stop it for today. If you are interested, feel free to ping me on my WhatsApp number or drop me an email or call me on my WhatsApp number. I can have a discussion.
Like one last question. Is SRVCTL and CRSCTL command is part of grid infrastructure software, or it can also be available as part of database software?
It's a part of your grid infrastructure, CRSCTL and SRVCTL. And as part of your database software, only SRVCTL.
Okay, okay.
Right. All right, guys. So let's connect on the coming weekend with the regular classes. And happy learning, guys. Thank you all.
Okay.